Hi all, in this video I will be discussing about ID3 algorithm and how to draw a decision tree using ID3 algorithm using a simple numerical example. The ID3 algorithm is a popular decision tree algorithm used in machine learning. It aims to build a decision tree by iteratively selecting the best attribute to split the data based on information gain. Each node represents a test on an attribute and each branch represents a possible outcome of the test. The leaf node of the tree represents the final classification. ID3 algorithm include the following steps. Calculate the entropy of every attribute using the dataset. Split the set into subset using the attribute for which entropy is minimum. Make a decision tree node containing that attributes. Recurse on subsets using remaining attributes. For building a decision tree, we first need to calculate the entropy of the entire dataset and entropy of individual attribute. Entropy is a measure of randomness in the information being processed. If the sample is completely homogeneous, the entropy is 0. That is, while we are considering a particular value and the value has only positive examples or only negative examples, the entropy in such case is 0. And if the sample is equally divided, then it has an entropy of 1. That is, if we have equal number of positive and negative examples, the entropy in such case is 1. Now, for calculating entropy of the entire dataset, the formula is entropy of S equal to minus P of I log P of I, that is minus probability of each class log probability of each class. Entropy of each sample is calculated as count of particular attribute by total count of sample into entropy of that attribute. Next, we have to find the information gain of each attribute using the above entropy values. Choose the attribute with the maximum gain and set as the node of the decision tree. Information gain is based on the decrease in entropy after a dataset is split on an attribute. Information gain can be calculated as gain of A given that this particular attribute S equal to entropy of entire dataset minus entropy of each sample. We can look how to build a decision tree using ID3 algorithm using simple numerical example. This is the dataset I will be considering for solving the numerical example. This particular example contains 14 examples, that is D1, D2 up to D14, for attributes like outlook, temperature, humidity, wind. Lateness is the target variable in this case. If we want to draw a decision tree using ID3 algorithm, the very first thing we need to understand is which is the attribute that gave the maximum information out of the available attributes. In this case, we have 4 attributes. Out of these 4 attributes, we need to calculate the information gain of every attribute. The attribute which is having the maximum information gain will be considered as the root node, and then we will start building the tree. So what we need initially is we need to calculate the information gain of each attribute in this example. So first we will consider the first attribute. The attribute name in this case is outlook. Possible values of outlook are sunny, overcast, rain. If we want to calculate the information gain, the very first thing we need is to calculate the entropy of whole dataset and the entropy of individual attribute values. So the entropy of entire dataset calculated as, here in this case the entire dataset is represented as S. On this particular dataset, we have 9 positive examples and 5 negative examples. Negative examples are marked as red. Entropy of the entire dataset, that is entropy of S equal to minus proportion of positive examples, that is equal to minus 9 by 14 log 9 by 14 to the base 2 minus proportion of negative example, that is minus 5 by 14 log 5 by 14 to the base 2. Similarly, we have to find the entropy of sunny, overcast and rain. So, entropy of the entire dataset in this particular example is 0.94. Next, we need to consider the dataset which is consisting of sunny for outlook. 5 examples are therefore sunny in this example. Out of 5, there is 2 positive and 3 negative examples. Entropy of S sunny equal to minus proportion of positive example, that is minus 2 by 5 log 2 by 5 to the base 2 minus proportion of negative example, that is minus 3 by 5 log 3 by 5 to the base 2, that is equal to 0.971. Similarly, we have to find the entropy of overcast. So we need to consider the dataset which is consisting of overcast for outlook. 4 examples are there for overcast. Out of 4, there are 4 positive and 0 negative examples. If we have only positive examples or only negative examples, the entropy of that particular dataset is always 0. We need not want to calculate the entropy. Sometimes we will have equal number of positive and negative examples. The entropy will always equal to 1 in that case, so that this can also be directly written. In this case, there are only positive examples for overcast, so entropy in this case will be 0. Similarly, we have to find the entropy of rain. So we need to consider the datasets which is consisting of rain for outlook. 5 examples are there for rain. Out of 5, there are 3 positive and 2 negative examples. Entropy of rain is calculated as minus proportion of positive example, that is minus 3 by 5 log 3 by 5 to the base 2 minus proportion of negative example, that is minus 2 by 5 log 2 by 5 to the base 2, that is equal to 0.971. Next, we have to find the information gain of this particular attribute outlook. That is, gain of outlook given this particular dataset is equal to entropy of whole dataset minus summation of cardinality of SV divided by S. SV means number of possible values of sunny, overcast, rain, and entropy of that particular value. Here it is equal to entropy of S minus 5 by 14 entropy of sunny minus 4 by 14 into entropy of S overcast minus 5 by 14 entropy of S rain. Gain of outlook given this particular dataset S equal to 0.94 minus 5 by 14 into 0.971 minus 4 by 14 into 0 minus 5 by 14 into 0.971 equal to 0.2464. Similarly, we need to calculate the information gain of remaining 3 attributes. So, the next attribute is temperature. Possible values of temperature are hot, mild, cool. First, we need to calculate the entropy of the whole dataset. Entropy of the whole dataset is as calculated before, that is, the entire dataset contains 9 positive examples and 5 negative examples. Entropy of entire dataset, entropy of S equal to minus proportion of positive example, that is minus 9 by 14 log 9 by 14 to the base 2 minus proportion of negative example, that is minus 5 by 14 log 5 by 14 to the base 2, that is equal to 0.94. Similarly, we have to find the entropy of hot, mild, and cool. First, we need to consider the datasets which is consisting of hot for temperature. Entropy of hot, that is, there are 4 examples. Out of that, 2 are positive and 2 are negative. So entropy of S hot is 1 directly. We need not want to calculate them because there are equal number of positive and negative examples. So entropy of S hot is 1. Similarly, entropy of S mild. There are 4 positive and 2 negative examples. So entropy of S mild equal to minus proportion of positive example, that is minus 4 by 6 log 4 by 6 to the base 2 minus proportion of negative example, that is minus 2 by 6 log 2 by 6 to the base 2, that is equal to 0.9183. Similarly, we have to find the entropy of S cool. 4 cases are there. Out of that, 3 are positive and 1 is negative. So entropy of S cool is equal to minus proportion of positive example, that is minus 3 by 4 log 3 by 4 to the base 2 minus proportion of negative example, that is minus 1 by 4 log 1 by 4 to the base 2, that is equal to 0.8113. Next, we have to find the information gain. Gain of temperature given this particular dataset S is equal to entropy of whole dataset minus summation of cardinality of SV divided by S. SV means number of possible values of hot, mild and cool, and entropy of that particular value. Here, gain of temperature given that S is equal to entropy of S minus entropy of each of these values. Gain of temperature given that particular dataset S is equal to 0.94 minus 4 by 14 into 1 minus 6 by 14 into 0.9183 minus 4 by 14 into 0.8113 equal to 0.0289. Next, we have to find the gain for attribute humidity. There are two possible values for humidity, high and normal. First, we have to calculate the entropy of entire dataset. Entropy of entire dataset is as calculated before, that is 0.94. Next, we have to calculate the entropy for high, S high. There are 7 cases. Out of that, 3 are positive and 4 are negative. Entropy of S high equal to minus proportion of positive example, that is minus 3 by 7 log 3 by 7 to the base 2 minus proportion of negative example, that is minus 4 by 7 log 4 by 7 to the base 2, that is equal to 0.9852. Next, entropy of S normal. There are 7 cases. Out of that, 6 are positive and 1 is negative. Entropy of S normal equal to minus proportion of positive example, that is minus 6 by 7 log 6 by 7 to the base 2 minus proportion of negative example, that is minus 1 by 7 log 1 by 7 to the base 2, that is 0.5916. Now, we have to find the gain of humidity given that particular dataset S is equal to entropy of whole dataset minus summation of cardinality of SV divided by S. SV means number of possible values of high, normal and entropy of that particular value. Here, gain of humidity given that S is equal to entropy of S minus 7 by 14 into entropy of S high minus 7 by 14 into entropy of S normal. Gain of humidity given that S is equal to 0.94 minus 7 by 14 into 0.9852 minus 7 by 14 into 0.5916 equal to 0.1516. Similarly, we need to calculate the information gain for attribute wind. There are two possible values for wind, strong and weak. First, we have to calculate the entropy of entire dataset. It is 0.94 as we calculated before. Next, we have to find the entropy of strong, that is S strong. There are 6 possible cases. Out of that, 3 are positive and 3 are negative. There is equal number of positive and negative cases, so entropy of S strong is 1. Next, entropy of S weak. There are 8 possible cases. Out of that, 6 are positive and 2 are negative. Entropy of S weak equal to minus 6 by 8 log 6 by 8 to the base 2 minus 2 by 8 log 2 by 8 to the base 2 equal to 0.8113. Next, we have to find the information gain of wind given that attribute S is equal to entropy of S minus 6 by 14 into entropy of S strong minus 8 by 14 into entropy of S weak, that is equal to 0.94 minus 6 by 14 into 1 minus 8 by 14 into 0.8113 equal to 0.0478. Once we calculate the information gain of all attribute, we need to check which attribute has maximum information gain. So if we compare all the 4 gains in this case, Outlook is having the maximum gain, that is 0.2464. So we will consider Outlook as the root node in this case. So once you consider Outlook as the root node, we need to check how many possibilities are there for Outlook. The first possibility is sunny, second overcast, and third one is rain. So here Outlook is a root node and we need to draw 3 branches. One is for sunny, other is for overcast and the other is for rain here. This is the one thing we need to consider. The second thing is whenever we consider outlook equal to sunny, we need to consider only D1, D2, D8, D9, D11. When it comes to overcast, we need to consider D3, D7, D12, D13. When it comes to rain, we need to consider D4, D5, D6, D10 and D14. And one more thing we need to notice is whenever we consider sunny as one branch, the target variable D1, D2, D8 are negative and D9, D11 are positive. So we cannot say what we need to put yes or no. This is actually how the tree looks like. Outlook as the root node, 3 branches, sunny, overcast and rain. D1, D2, D8, D9, D11 are the examples where sunny is present. D3, D7, D12, D13 are examples where overcast is present. D4, D5, D6, D10 and D14 are the example where rain is present. As said earlier, while considering sunny, we have 2 positive and 3 negative examples. We cannot write yes or no label here. So while considering overcast, there is only positive examples, so we can directly put the label yes. While considering rain, there are 3 positive and 2 negative examples, so we cannot say whether the label is yes or no there. What we need to do is consider the 5 values of sunny, that is D1, D2, D8, D9 and D11, and check whether which attribute should be returned there. Similarly, in case of rain, consider D4, D5, D6, D10 and D14 and consider which attribute should be returned there. Now consider sunny. While considering sunny, only 5 examples are considered: D1, D2, D8, D9 and D11, and 3 attributes: temperature, humidity and wind is considered because outlook is already considered. Next, we have to find the information gain of temperature. The attribute temperature has 3 values: hot, mild and cool. First, we have to find the entropy of entire data set. Here 5 data set are there. Out of that, 2 are positive and 3 are negative. Entropy of entire data set S sunny is equal to minus proportion of positive value, that is minus 2 by 5 log 2 by 5 to the base 2 minus proportion of negative value, that is minus 3 by 5 log 3 by 5 to the base 2 equal to 0.97. Next, we have to find the entropy of hot. There are 0 positive values and 2 negative value, so we can directly write the entropy as 0. Next, entropy of S mild. There are equal number of positive and negative value, so we can directly write the entropy as 1. Next, entropy of S cool. Here there is 1 positive value and 0 negative value, so we can directly write entropy as 0. Now we have to find the information gain. Gain of temperature given that this particular data set S is equal to entropy of all dataset minus summation of cardinality of SV divided by S. SV means number of possible values of hot, mild and cool and entropy of that particular value. Here gain of temperature given that S sunny equal to entropy of S minus 2 by 5 into entropy of S hot minus 2 by 5 into entropy of S mild minus 1 by 5 into entropy of S cool. That is gain of temperature given that S sunny equal to 0.97 minus 2 by 5 into 0 minus 2 by 5 into 1 minus 1 by 5 into 0 equal to 0.570. Next, we have to find the gain of attribute humidity. Humidity have 2 possible values, high and normal. First, we want to calculate the entropy of entire dataset. It is 0.97 as calculated before. Now, to find the entropy of S high, there are 0 positive and 3 negative value. So, we can directly write the entropy of S high as 0. Now, to find the entropy of S normal, there are 2 positive and 0 negative values, so entropy of S normal can be also written as 0. Now gain of humidity given that particular dataset S sunny equal to entropy of entire dataset minus summation of cardinality of SV divided by S. Here SV means number of possible values of high and normal, and entropy of the particular value. Here entropy of humidity given that Sn equal to entropy of S minus 3 by 5 into entropy of S high minus 2 by 5 into entropy of S normal. That is gain of humidity given that Sn equal to 0.97 minus 3 by 5 into 0 minus 2 by 5 into 0 equal to 0.97. Next, we have to find the gain of attribute wind. Possible values of wind are strong and weak. First, we need to calculate the entropy of entire dataset. It is 0.97 as calculated before. Next, we have to calculate the entropy of S strong. There is one positive and one negative value in this case. So, entropy of S strong we can directly write it as 1. And next, we have to find the entropy of S weak. There is one positive and two negative values. So, entropy of S weak equal to minus 1 by 3 log 1 by 3 to the base 2 minus 2 by 3 log 2 by 3 to the base 2 equal to 0.9183. Now, we have to find the gain of wind given that particular dataset Sn equal to entropy of S minus 2 by 5 into entropy of S strong minus 3 by 5 into entropy of S weak. That is gain of wind given that particular dataset Sn equal to 0.97 minus 2 by 5 into 1 minus 3 by 5 into 0.918 equal to 0.0192. Now, we list the gain of every attribute here. Gain of temperature equal to 0.570, gain of humidity equal to 0.97, gain of wind equal to 0.0192. Now, out of these three, humidity is having the maximum gain. Considering humidity as label, there are two possible values for humidity, high and normal. High is appearing 3 times and normal appearing 2 times. Whenever it is high, the label is no, and whenever it is normal, the label is yes. So, directly we can write the label no for high and the label yes for normal. So, this is the tree we have drawn in previous iteration. In this iteration, we consider humidity as node. Whenever we have high, there are 3 examples. All of them are no. And whenever we have normal, there is 2 examples. Both are yes. So the tree looks like this. Next, we have to consider rain and calculate the node which has maximum information gain. We will consider these 5 examples D4, D5, D6, D10 and D14 and calculate which will have the maximum information gain. Considering these examples, we have to find the gain of temperature, wind and humidity. First, we are considering the attribute temperature. Possible values of temperature are hot, mild and cool. First, we have to find the entropy of entire dataset. We have 3 positive and 2 negative values. So, entropy of S rain equal to minus 3 by 5 log 3 by 5 to the base 2 minus 2 by 5 log 2 by 5 to the base 2 equal to 0.97. Next, we have to calculate the entropy of S hot. We have 0 positive and 0 negative value. So, we can directly write the entropy of S hot as 0. Next, we have to find the entropy of S mild. We have 2 positive and 1 negative value. So, entropy of S mild equal to minus 2 by 3 log 2 by 3 to the base 2 minus 1 by 3 log 1 by 3 to the base 2 equal to 0.9183. Next, we have to find the entropy of S cool. Here we have equal number of positive and negative value, that is 1. So, we can directly write the entropy of S cool as 1. Next, we have to find the gain of temperature given that particular dataset S rain equal to entropy of S minus 0 by 5 into entropy of S hot minus 3 by 5 into entropy of S mild minus 2 by 5 into entropy of S cool. That is gain of temperature given that particular dataset S rain equal to 0.97 minus 0 by 5 into 0 minus 3 by 5 into 0.918 minus 2 by 5 into 1 equal to 0.0192. Similarly, we need to find the gain of attribute humidity. Humidity have two possible values, high and normal. First, we have to calculate the entropy of entire dataset S3, that is 0.97 as calculated before. Next, we have to find the entropy of S high. There is one positive and one negative. Here we have equal number of positive and negative value, so the entropy can be directly written as 1. Next, we have to find the entropy of S normal. We have two positive and one negative value, so entropy of S normal equal to minus 2 by 3 log 2 by 3 to the base 2 minus 1 by 3 log 1 by 3 to the base 2 equal to 0.9183. Now we have to find the gain of humidity given that particular dataset S rain equal to entropy of S minus 2 by 5 into entropy of S high minus 3 by 5 into entropy of S normal. That is gain of humidity given that a particular dataset S rain equal to 0.97 minus 2 by 5 into 1 minus 3 by 5 into 0.918 equal to 0.0192. Next, we have to find the gain of attribute wind. Wind have two possible values, strong and weak. First, we have to find the entropy of entire dataset. It is 0.97 as calculated before. Next, we have to find entropy of S strong. We have 0 positive and 2 negative for strong. So, entropy of S strong can be directly written as 0. Next, we have to find entropy of S weak. We have 3 positive and 0 negative examples. So, entropy of S weak can also be written as 0. Next, we have to find the gain of wind given that a particular dataset S rain equal to entropy of S minus 2 by 5 into entropy of S strong minus 3 by 5 into entropy of S weak. That is gain of wind given that a particular dataset S rain equal to 0.97 minus 2 by 5 into 0 minus 3 by 5 into 0, that is 0.97. We have calculated the gain of three attributes. We compare all this. Gain of temperature equal to 0.0192, gain of humidity equal to 0.0192, gain of wind equal to 0.97. So, wind is having the maximum information gain. Wind will be considered as node. While considering wind as node, there are two possibilities, strong and weak. While considering wind is weak, it is appearing 3 times, and all these cases it is yes. So, we can directly write yes. While considering wind is strong, there is no only. So, we can directly write no. This is the tree we have got in this iteration. Wind is considered as root node. We have two possible values, strong and weak. Strong is having 2 examples, all 2 are no, and weak is having 3 examples, all 3 are yes. So we can directly write yes. No need for further calculation or draw the decision tree. This is the procedure to follow while drawing an ID3 decision tree algorithm. Thank you for watching.